Okay, welcome guys to today's video. Today we'll be talking about outliers and how we can detect outliers using the Z-score and IQR statistical method. I'm quickly going to put my screen on presentation mode. What are outliers? Outliers are data points that are far apart from the average data points in a given data set. As seen in this chart here, this is a scatter plot. We can see that one point is far apart from the rest of the data point cluster. This data point is the outlier. How why do we need to identify outliers in the data set? Identifying outliers in the data set is important because if we don't identify them and we go on with our statistical analysis, it will impact negatively on our statistical analysis results. This is one reason why detecting and eliminating outliers is very important. Also, in machine learning, outliers can significantly affect the results and performance of your machine learning model if they are not taken care of. Now, what are the causes of outliers? Outliers are caused by several factors which I have listed here. One, measurement errors. Two, sampling errors, natural variability, data entry errors, experimental errors, and intentional outliers. Intentional outliers occur during fraudulent activities. They are inserted to cause distortion of the data set. These are often carried out during fraudulent activities. Now, in the next slide, we are going to see the different ways we can detect outliers in our data set. I'm going to quickly move to the next slide. Outlier detection methods. One of the easiest way to identify outliers in a data set is through plots. There are different kind of plots that we can use to spot out outliers. One is the box plots, scatter plots, and violin plots. In my previous video, I took time to explain and show how box plots, scatter plots, and violin plots can be used to identify outliers in a dataset. Now, the second way we can identify outliers in our dataset is through statistical methods, which is the main focus of today's video. One is the Z-score and the two is the interquartile range or IQR. Z-score is also called a standard score. This value helps us to understand how far the data point is from the main data point in the data set. And we can identify outliers using these methods by setting up a threshold value of the Z-score so that data points that are far apart from this threshold value are identified or isolated as outliers. Now, interquartile range. Interquartile range approach to finding outliers is the most commonly used and most trusted approach used in the research field. In my next screen, we are going to show you in detail using Python how we can use excuse me, how we can use the Z-score and the interquartile range to identify and eliminate outliers. So I'm quickly going to escape the screen. Then I'll go to my next screen, which is my Python, my Jupyter notebook. Now, this is uh, a sample. This is just a small fraction of an exploratory data analysis, the aspect of identifying and eliminating outliers. So to be able to eliminate outliers, what I'll be working with is my pandas, numpy, seaborn. The first step, I will need to import these libraries, then run them. Now in my line 2 is where I import my data set onto my Jupyter notebook. In this video, I'll be working with this data set that talks about exam score of different faculties of different universities, as we can see in the first 5 entries of the data. So the main focus on this data set will be in the exam score column. So I'll be identifying outliers on this column. I'll identify the outliers and eliminate them accordingly. So the first method is using the Z-score method. So how am I going to approach this? First, I'm going to calculate the Z-score of the entire exam score column of this my data set. After which I'm going to specify a threshold value of the z-score such that the z-score values of the exam score column that are far apart or that are greater than the threshold value or less than the threshold value, I'm going to eliminate them out. So line 4 is the command that calculates the z-score value for the exam score column. As you can see here, this is the exam score column. That is the column I'm working on. So the output of this code is what we are seeing here, the first 5 and the last 5 data. So we can see that in the first 5 output of our z-score, the average of 2, and the last 5 we can see 1, 2, 2, 2, and 3. So this is the first stage of using the z-score approach to identify outliers. The first thing is to calculate the z-score for the data set you are looking for the outliers on. Now the next thing I'll do is to set my threshold value. The threshold z-score value is what I'm going to set. So as you can see here in line 5, I have set my threshold value to be 2. What does that mean? What does this threshold value signify? The threshold value is the boundary, is the boundary point of which any data entry that is greater than this threshold value is considered an outlier. So in the next line, in this next line, I've created this is in this next line I've created a function that specifies what the outliers will be. That is values greater than the threshold values, which is 2. So any value that is greater than 2 will be considered as an outlier. That is what this function stands for. Next, I've also created another function that extracts these identified outliers from the exam score column. So we can see no outliers equals to Erasmus, which is uh, my data set dot drop in bracket outlier indices. So what this line means, what this function means is the outliers identified in the outlier indices function, this other function, no outliers, removes them from my original data set. Then in this third line prints the original data set, and the last line prints the data set after the outliers have been removed. So as you can see, the original data set we have 30, 37, 341 rows and 7 columns. In the modified data set, we have 332 rows and still 7 columns after our outliers have been removed. Now, we would love to see our outliers. That is what line 6 is trying to tell us. So the outliers in our data set occurs in row 1, in row 0, row 1, row 2, row 3, row 4, row 337, row 338, row 339, and row 340. Let us confirm these. So if we come back to line 4, where the z-score values are displayed for the first 5 and the last 5 values, we can see that these z-score values are greater than 2, apart from row 336. So they are all considered outliers except row 336. So let's go and see if we have row 336 among this. We don't have row 336 here. So if 337, 338, 339, and 340, those are where our outliers can be found and they've been removed from our data set. Very simple. We can use this Z-score. I used the Z-score method to identify and eliminate these outliers from the SciPy library. The SciPy library is a very powerful Python library that we can use to carry out statistical analysis. So the next thing we do, let us see how we can use our interquartile range to also identify and eliminate outliers in our data set. So the first thing we do is to calculate our quartiles, our Q1 and Q3. What are quartiles? Quartiles are fragments in our data set that helps us to determine points that we need and points that we don't need on our data set. And we'll be using the midpoint approach. What does it mean? So the Q1 represents 25% of the entire data set, which is the first quartile. The second quartile is the median point in our data set. And the third quartile represents 75% of the entire data set. So our interquartile range is usually Q3 minus Q1, which will give us our interquartile range, of which we have calculated here. Interquartile range is equal to Q3 minus Q1, and we've printed our interquartile range to be 11.71. 11.71. Excuse me. Now, the next thing we do is to evaluate our upper bound and our lower bound limits to enable us get the set points of which values are outside we consider as our outliers. So to calculate the upper bound, we add 1.5 plus, we add 1.5 times our interquartile range to our Q3 value, which we've done here. And like I mentioned earlier, we are considering the exam score column. Our lower bound, we subtract 1.5 times our IQR from our Q1 value. Still on our exam score column, we have the lower bound. So I've printed our upper bound value and our lower bound value. Our upper bound value is 102.845 and our lower bound value is 56.004. So we'll be working with these such that values that exceed 102.845 are outliers and values that fall below 56.004 are also considered as outliers. So the next thing we do after determining our upper and lower bounds is to identify or detect for these outliers. That is the next thing we're going to do. So these first lines of code in our line 9 input are, I'm just importing the original data set to show you the shape before removing the outlier. So now we go into the detection proper. So like I mentioned, we've calculated our Q first quartile and third quartile. We've also gotten an interquartile range. Our lower bound, like we showed previously, is Q1 minus 1.5 times our IQR. Our upper bound is Q3 plus 1.5 times our IQR. Now the next thing is to create arrays of Boolean values indicating our outlier rows. That's why we see these two codes here. We are trying to see values that are above our upper bound, and we're also trying to see values that are much below our lower bound. That's why we have here upper array equals to np.where Erasmus is our data, raw data, then exam score is the column we are working on. So after we've identified values that are outside our upper and lower bounds, we consider them as outliers. Then the next thing is to remove these outliers from our data set. That's why we have here Erasmus.drop index upper array in place true. Values for which this code is true is an outlier and it will be removed. Values for which index equals to lower array in place true means values that are below our lower bound limit is going to be dropped from the original data set. That's what these lines of codes are trying to tell us. Then the next thing is to print the new data set after our outliers have been removed. So that's what we're seeing here. The old shape, which is the original data set, is 341.7. That's 341 rows, 7 columns. And the new data shape after the outliers have been removed is 340 rows, 7 columns. That means only one row is considered an outlier from the exam score column. So we can see how easy it is to detect outliers in a data set using both the Z-score and the IQR values. IQR statistical method, sorry. If you have any questions, please hit the comment section and drop them. I'll be much willing to answer your questions. And don't forget to subscribe to this channel to get more exciting videos like this. Thank you very much and see you in our next video.